are all hooked together and hooked to either power or ground. Okay, they're hooked to power. So 1, 2, 3, or 2, 3, 4 are all hooked to power. So I'm guessing that ties them in the good state. It wouldn't make much sense any other way. Pin 5, which is clear. 2, 3, 4. Oh boy. Pin 5, which is clear, sort of runs off to who knows where. Going right under that cap. Snakes through there. I don't think it comes into this one. Oh, it does. Eight, 7, 6. 8, 7, 6 goes to pin 6 on the LM10. Pin 6. I'm hoping that's a power or ground pin. That's that reset line, so that makes sense. So part of what this chip's purpose in life is, and I may keep it for this reason, is if the sign's not running correctly, that reset line will hold the column drivers in the off state. So you wouldn't have to worry about the case that there's a bad word stuck in this latch where it's turning all 8 columns on, which would then overload this transistor, because he's only rated, or I assume rated, to run 1 LED at a time. So that's the reset pin. Now the input to the pulse stretcher comes in on pin 1, and it's hooked to pin 11. So it's kind of interesting. So when a pulse comes in to set a word into this guy, it starts this pulse stretcher, and when it times out, it changes the state of the output enables. So again, this is probably part of the protection circuit for this thing running at a higher rate of speed. So back towards the beginning of this video, I talked about the current on these LEDs. When you're doing this persistence of vision scanning to do this display, if you run these LEDs at their nominal current, whatever that may be, and scan it at a 1/8 duty cycle, they'll appear to the person 1/8 as bright, because they're honestly only on for 1/8 the time. A way to overcome that dimness is to overdrive the LED. Now, if you overdrive an LED at 100% duty cycle, it will burn out. I mean, you're overstressing the device. But you can overdrive an LED for a small period of time. The same sort of idea is for PWM circuits where you're driving motors and fans. You got this normal sized FET doing a lot of current for a very small window of time, and it's usually listed as pulse time, and it can handle that just fine. But if it did that same amount of current continuously, it'd burn up because it just thermally can't take the load. So what this combination of circuit here does is when you write in a word into this thing to pick one of these LED row drivers, it will only leave that row on for that predetermined amount of time. So there's no way you can overdrive the LEDs if the micro crashes or some interrupt happens where it doesn't come back in time to service this latch to turn the LED back off. So it's sort of a hardware safety built into the card. Now, I may keep that because it just, it's just sort of a fail-safe, don't care, this will do what I need to do, and I don't have to worry about if I have a bug in my code of burning all my LEDs out or something else on the card. Now, one thing I'll have to do once I start depopulating everything else on here is scope up this chip, send a pulse into this, and see what the output time is. And then I need to set up my interrupt loop in my code to be slightly longer than that interrupt, or that timeout. Actually, it could be the same length of time since that's retriggerable. Yeah. So I need to set up my scanning of the LEDs to slightly shorter than that timeout. So every time I come around and poke a byte in here, it will open up the enable window for another chunk of time. So we'll never have a slice where one LED is out or is turned off out here. So that's a pretty cool chip and a pretty cool way they have it set up. Unfortunately, I have to dig through all this little crud here to truly understand how it's hooked up and how it's working, and make sure I'm using it correctly. Now, the reset line there is what keeps this thing on power up from displaying anything on the screen until it's ready to go. I don't think I'm going to use that feature, so I'll just tie that line into a happy state for now. I may bring it out and use it for something, I just don't know what yet. So, what time is it? It's almost 5. I have to be someplace at 5, so I think this is going to be it for this weekend. I got enough film in the can, so to speak, to be posting these videos for quite a while, since my PC really does not like the higher bandwidth or the larger file size that these videos are. So again, I switched cameras to one with a wider fisheye lens, and also I reduced the video quality a little bit just to try and rein in the file size. If you like this video, leave a comment. If you want me to switch back to the old camera, leave a comment, and then we'll go from there. I think the next part I'm going to do is I'm probably going to depopulate these chips, because if you remember, that's this structure here, which under the new microcontroller I'm not going to need. I just need these two decoders. I also can depopulate this and part of this circuit and tie the reset line to this guy so it's always inactive. And then this chip I need to finish poking around to make sure there's nothing else on it that I care about. I think the only thing on there is that address. Nope, there's a little bit more on the backside, so yeah, I need to poke through this and make sure that none of this other stuff is something I need. This may all be related to this keyboard connector. It could be related to some of the clock circuit around this guy. And I also need to trace out the crystal and clock and get that off the card too. So I think next time when I start up, plug in the soldering iron, pop these two chips, trace and pop this circuit, and then trace these two and pop whatever's not needed there, tying this one into the whatever the good happy state is. After that is done, I got to make a decision on how I'm going to arrange two of these cards together, whether I'm going to slice and slice, or if I'm just going to slice the ends and let the second card stick up. So there'll be more construction concerns on that later. Also off camera, I'm going to try and get some of those new microcontrollers with 4K of RAM and the 64 meg internal oscillator on order, so they're here and ready to go once I'm ready to start doing some firmware programming. But that is all I have for this weekend, and I'll continue this on another weekend. Laters.